Assalamualaikum and good day. I bid to our lecturer, Dr. Muhammad Idris. My name is Nur Aniza binti Siddiq and my group mates, Muhammad Arif Fadilah and Wanuhani Narina, will present about thermal analysis on topic thermogravimetric analysis and kinetic of mixed combustion of waste plastic and semi-cooled. Okay, for introduction, the enormous use of plastic product in daily life has caused more and more serious white pollution problems. So, it is urgent to develop the new practicable and sustainable treatment technologies. Okay, new method for reusing waste plastic that involve thermal analysis is waste plastic injected to blast furnace with semi-cooled. Why thermogravimetric analysis technology is widely used? Because of its simple operation process and large amount of data. Some combustion characteristic values such as ignition temperature, burnout temperature, peak reaction temperature, maximum combustion rate, average combustion rate, and combustion time can be obtained through thermogravimetric analysis.
I'm Muhammad Arif Fadilah bin Abdul Aziz. Right now, I would like to continue at the objective. The first objective is to analyze the similarities and the difference of waste plastic and semi-cooled by proximate analysis and ultimate analysis. Second, to discuss the combustion characteristics of the mixture of waste plastic and semi-cooled by thermogravimetric analysis at different heating rates. And the last one is to research the synergistic effect between the combustion of the mixture. Next, for the methodology, the raw material for this experiment is semi-cooled and waste plastic. It can be seen from table 1 that the volatile content of waste plastic is far greater than that of semi-cooled, and the ash content is opposite. The sulfur content is 0, which means its pollution is small and has good advantage for blast furnace injection. Next, for thermogravimetric analysis, the sample will dry under the sun for 7 days to separate out water. The semi-cooled was shredded into particles in sizes of about 5 mm and subsequently crushed to -0.200 mm in a self-designed crushing system. Waste plastic, after washing, drying, low temperature soft melting, and cooling treatment, the -200 mesh waste plastic powder was obtained. Afterward, the particle sizes of sample were selected to that lower than 0.074 mm by using standard test sieve. The mixture were prepared according to the proportion of 100%, 80%, 60%, 40%, 20%, and 0% of waste plastic powder. Then, they were ground for 20 minutes to mix evenly. The sample weight was approximately 10 mg and was placed in an aluminium trioxide crucible. Then the aluminium trioxide crucible was placed in a TG bracket. That's all from me. Thank you.
So now, I'm going to explain about the result analysis for thermogravimetric analysis of waste plastic and semi-cooled. The TG curve of the mixture between individual waste plastic and semi-cooled sample show that as the amount of waste plastic increased, the TG curve of the mixture moved to the low temperature zone. However, the trend of the TG curve of the mixture took into characteristic of individual sample. From the TG curve, we know that an initial stage of combustion existed between ambient temperature and 654.86 to 678.26 Kelvin due to the softening of waste plastic and semi-cooled, as well as the precipitation of volatile matter. Then, the largest peak was observed at 743.27 to 752.35 Kelvin. In this stage, the mixture of waste plastic and semi-cooled thermally decompose a large amount of volatile metal and burn rapidly. Finally, we can see that the temperature rose to 910.24 to 918.27 Kelvin. The loss of weight mainly was due to the combustion of fixed carbon in the mixture, which was called the second stage. It was very complicated to analyze the mixed combustion process of waste plastic and semi-coke. Therefore, in order to determine whether there was synergistic effect in the mixed combustion process, the average conversion value of waste plastic conversion and semi-coke conversion in the single combustion process was compared with the experimental value. The existence of synergistic effect is related to the difference between calculated value and experimental value. By assuming that there was no interaction between the mixture, the overall mass loss of the mixture was the average mass loss of the individual. So, the calculated value can be determined using this formula. In the formula, alpha is represent the mass percentage of waste plastic, while beta represent the mass percentage of semi-coke in the mixture. The comparison of experimental value and calculated value at 10 Kelvin per minute was shown in figure 4. From figure 4, we know that the experimental data and calculated data had good similarity, but the deviation between experimental data and calculated data demonstrate that waste plastic interact with semi-coke. So, from the graph train in figure 4, it can be seen that there was synergistic effect in the combustion process of waste plastic and semi-coke mixture, where the experimental value in the first stage is lower than calculated value gives a negative synergistic effect. However, the synergistic effect in the second stage is positive because the experimental value shown to be higher than calculated value. The value of combustion characteristic is determined by the TG and DTG curve in order to further study about the effect of waste plastic addition on the semi-coke combustion process. The Comprehensive Combustion Feature Index S includes several key feature indices during combustion. It comprehensively reflects the burning characteristic of pulverized coal. The higher of value of S, the better its combustion characteristic, as defined in the following equation. The difficulty of igniting the combustible is indicated by flammability index C and related to the arcment and the ignition temperature. It could be seen from table 2 that the ignition temperature and burnout temperature of waste plastic were lower than those of semi-coke, as waste plastic fraction was increased from 0% to 100%. The ignition temperature Ti and burnout temperature Th decreased from 568.25 Kelvin to 563.554 Kelvin and 978.257 Kelvin to 798.55 Kelvin respectively. Meanwhile, arcmax 1 and arcmax 3 decreased, but arcmax 2 increased while the maximum burning rate arcmax decreased. With the increase of the waste plastic content, the flammability index C and the comprehensive combustion characteristic index S of the mixture increased. Hence, from this result, it could be concluded that the combustion characteristic of semi-coke could be improved by addition of waste plastic, while it was the same as ignition property, which provide a theoretical basis for blast furnace injection of waste plastic and semi-coke.
Okay, for part B, which is effect of heating rate on combustion process mixture. There are two graphs, which is the first one is figure 5, show that TG curve of adding 60% with plastic content, and figure 6 show that the TG curve of adding 60% with plastic content. As you can see that, based on the graph trend, TG and DTG curve both move to the high temperature zone as the heating increased from 2.5 Kelvin per minute to 20 Kelvin per minute, resulting a phenomenon known as thermal hysteresis. Okay, there are two factors that resulting thermal hysteresis, which is the first one is the single reaction did not have enough time to react and develop with the adjacent high temperature, as the increase in heating rate has forced the temperature to rise faster. And the second one is the overall temperature gradient cross-section of the sample increased at the higher heating rate, resulting a large temperature difference between the inside and outside of the sample. The diffusion rate on the surface of the combustion product is relatively slow to hinder the combustion of internal combustibles, which is used to effect the heat transfer between the thermogrammetry instrument and the sample. Okay, table 3 show that combustion characteristic parameters of mixture adding 60% with plastic content. As you can see that when heating rate increased from 2.5 Kelvin per minute to 20 Kelvin per minute, the ignition temperature, which is Ti, the burnout temperature, Th, comprehensive characteristic index, S, and the flammability index, C, also increase. But the risk of both T initial and T final often means deterioration of combustion properties of the mixture. However, a clear promotion effect on combustion was more significant. As a result, it can conclude that high heating rate could improve combustion properties of the mixture. Okay, for conclusion, we can conclude that thermochemical method was used to investigate the mixed combustion of waste plastic and semi-coat. The mixed combustion process of waste plastic and semi-coat conclude volatile combustion stage and fixed carbon combustion stage. Addition of waste plastic can improve comprehensive combustion characteristic, which is S, and ignition properties of semi-coat. There was synergetic effect in the combustion process of waste plastic and semi-coat mixture. The mixed combustion process of waste plastic and semi-coat could be well stimulated by the n-order rate module of double parallel reaction. Okay, the last one is the activation energy, which is E, in the first stage of combustion were higher than in the second stage, while the pre-exponential factor, which is K, was opposite. Okay, that's all from us. Thank you.